Hi, students. It's Mr. Nguyen here. Today we are going to discuss about the two theorems of tangents. This goes with your lesson 9.2. Okay, so you are expected to know the relationships among all of these things, right? Last time we talked about the chords. This time we're going to be talking about the tangents, right? There are only two theorems that goes with the tangents. One is a segment theorem, and the other one is an angle theorem. And just keep in mind, these theorems have a lot of applications, so we'll be looking at other ways that these theorems are being used as well. Okay. So first of all, before we talk about the tangent theorem, let's talk about the definition of what a tangent is, right? So what is a tangent to a circle? Well, a tangent is a segment that intersects a circle at only one point. As you can see, that pink line right here, or the red line right here, that touches the circle right here at point T, is called the tangent line, right? The tangent line. This tangent line has a point right here. This is called the point of tangency, appropriately named, right? The point of tangency. So this line is called the tangent, right? It has some properties. It is perpendicular to the radius. If you draw the radius from the center of this circle to touch this tangent at point T, that angle is actually a 90-degree angle. And that's the property of the tangent line. It is perpendicular to the radius, okay? And so every time you have perpendicular lines meeting at somewhere, you know that if you draw a secant line, this line is called a secant line. This secant line because it's a line that goes through the circle, right? A tangent line touches the circle on the outside, but a secant line touches the circle at 2 points because it goes through the circle. If you draw this tangent line, and if you see there's a right triangle that forms right here. So what does that imply? What implies that you can use the Pythagorean theorem to solve for some of these missing segments, right? Like the radius or the tangent segment or even the chord, right? So you're gonna see these problems being applied later. So let's talk about the first theorem. The first theorem is a segment theorem. It says that if there are two segments of tangent that meet, they're equal to each other. Okay, so the exterior segments of two tangents are equal to each other when they meet. Right, they meet right here at point B. So this is tangent AB, and here's tangent BC. They meet at point B. Well, they happen to be equal to each other, always, right? So that's an easy enough theorem. So those two segments are the same. All right, let's apply them real quick. Okay, well, it looks completely different here in this picture. So what are we supposed to find here? They give us, as you notice, there's this line right here, AB is tangent, and this line right here, AD, is also a tangent. And then we have radius here. BC is a radius, and CD is a radius, right? And then they also give us the segment that goes from the center to the point where they intersect, which is AC. This line is 52. This segment is 52 units long, right? So let's talk about all of these things we have to find. We have to find x, the value of x, right? We have to find angle ABC. Angle ABC is this angle right here, okay? And then we have to find segment BC. Segment BC is the radius. And then we have to find the diameter. Okay, so the diameter, after you find segment BC, you can just extend that segment and you will get the diameter. So let's see how we do this. Let me hide this little box here. So let's first talk about the first theorem that we just talked about. That says that when two tangents meet at a common point, which is point A right here, we know that the segments are equal. So we know that AB and AD are congruent. So we're going to use this relationship to say that 2x minus 13 is equal to 48. And this is a simple two-step equation you can solve to get the value of x. So you're going to add the 13 to the other side. You're going to get 2x equals to 61. And to solve for x, you divide both sides by 2. and you get the x value to be 30.5. So far we found one answer, 30.5. The angle ABC actually comes from the property of a tangent line. Remember, we talked about the property of a tangent line being perpendicular to the radius. So, because it is perpendicular, it creates a 90-degree angle. Therefore, angle ABC is 90 degrees. So, that's pretty straightforward, just using the property, right? To find BC, notice BC and CD are actually equal because they're both radii, right? They're the radius of the circle. Okay, so how are we going to use this relationship? How are we going to use this relationship? Well, if you look underneath here on the bottom segment, you can see that this is a right triangle because, of course, this is angle D right here is also a right angle, right? Angle ADC is also a right angle. And because it is a right angle, we have a right triangle here. And we can use the Pythagorean theorem to find segment CD, right? So we have A, B, C. So we can do um, C squared minus B squared to give us A squared. So you can use the Pythagorean theorem down here to solve for segment CD, right? Or segment BC, okay? So it's 52 squared minus 48 squared, and then you will take the square root of that, which is 400, and then you will get 20. So segment BC is equal to 20, right? Because segment BC is 20, it is the radius, and the diameter of the radius is 2 times the radius, so you just add another 20 to get the diameter. Okay, you take a minute to review that problem before we move on. Okay, next one. Next example, we have tangent AB, and they drew a little segment over here. This is a secant segment that goes through this circle, and it create a right triangle here. And we're supposed to find the value of x, which is this little piece. Now notice, if this is the radius, then this down here is also the radius. This little short piece right here is also a radius. Okay, so we're gonna use that fact to solve for x. Okay, so if this is 5, this is also 5, right? So we can use Pythagorean theorem here. So it's a squared plus b squared equal to c squared. Well, c squared is this whole thing. It's 5 plus x, right? But let's see how we do that. CA. To find CA, you do a squared plus b squared, right? So 5 squared plus 12 squared. And then you take the square root of that, you get 13. Now, 13 happens to be the whole entire thing, which is segment CA. But the problem only asks us to find this little outside segment, which is X right here. But the whole thing is 13, and the radius itself is already 5. So what's left over? 8. So you do 13 minus 5 gives you 8, which is the outside segment. Next, here's another application of what we just learned, okay? So there is a circle drawn inside a polygon. This is called inscribed, right? So the polygon circumscribes the circle. Circumscribe mean it is on the outside, right? Inscribed is inside. So the circle, it's inscribed, but the polygon circumscribes, right? So the polygon is outside. Well, if you notice, these little pieces over here are actually tangents, right? These are tangents. So we have one tangent, two tangent, three. So these are all tangent segments that touch the circle at one point, right? So in order to answer this question, perimeter, we have to add CA, we have to add CE, we have to add EG and AG all together. So perimeter means all of these add together. So let's find them. So we have to find all of these segments. We have to find AC. Well, AC is easy. It's just 3 plus 2. Okay, it's that first segment right here, 3 plus 2. To find CE, To find CE, you have to know CD. Well, CD is a tangent that comes from the same point with this tangent. So according to that theorem, they are equal to each other. So it has to be a 2. All right, so this is 2 and that's 2. Well, then that means CE will also be 2 plus 3, which is 5. Same thing for EG. If we want to find EG, we have to know EF and we have to know FG. Well, EF is the same distance as ED because they are tangents and they meet at the same point. According to the theorem, they are equal to each other. So EF is 3. And you can use the same thing for FG. FG is the same as HG. So that's 1. So the whole segment for GE would be 4. And then same thing for AH. AH happened to be 3 because it is the same segment as AB. Okay. And so the whole segment for AG would be 3 plus 1, or 1 plus 3 would also equal to 4. Now that we found each individual segment, we add them all together and we will get the perimeter. So 5 plus 5 plus 4 plus 4 is 18. Okay, so this is another application of that tangent segment theorem that we just talked about. Okay, let's move on to the second theorem of these tangents, and this has to do with angle, and it's pretty simple. Now notice if the two tangents meet, it will create as an angle on the outside of this circle. It is called the exterior angle, right? So this exterior angle created by two intersecting tangents is half of the difference between the major arc and the minor arc. So in plain English, it says if you take the major arc and you subtract the minor arc and divide the answer by half, you get the angle on the outside. So here's your exterior angle, angle A. There's your two tangent, tangent 1 and tangent 2. There's the major arc and there's the minor arc. If you subtract these two arcs and divide it by 2, it will give you the outside angle. That's what this theorem says. So let's apply that real quick. Okay, so here we have a missing angle. Okay, so the measure of angle A is the difference of the two arcs divided by 2. Well, the two arc here is going to be arc DE. Well, this is a major arc, or the bigger arc on the outside. And then arc BC, which is the smaller arc on the outside. You will subtract them and you divide it by 2 to give you angle A. So let's get some more information. Well, arc DE is given to us. It is 125 degrees. So if we subtract that from BC, well, they have to give us arc BC, otherwise we can't do this. Well, arc BC is 27. So these are given information, right? These are not found. We didn't find these. These have to be given to us, right? Uh, and now we can apply the formula. So it's going to be 125 minus 27 divided by 2. So you would subtract first and then you divide, okay, because the subtraction is done together on top, and then divide the difference, okay, and you get 49 degrees. So angle A, the measure of angle A is 49 degrees. So here's another one. This one, they give us the major arc and they give us the and nothing else. That's it. And so we have to use this formula. But before we have to use the formula, we have to find, oh, the arc here is misspelled. Sorry about that. It's acre. Sorry, it's supposed to be ARC. Anyway, minor arc, the minor arc is this piece in here. So it's whatever left from 360, right? Because the major arc itself is 265. So the minor arc must be 360 minus 265, which is 95 degrees, right? So we're going to apply the formula. We said major arc, 265, minus minor arc, which is 95, and divided by 2, we would get the exterior angle, which is x, which happens to be 85 degrees. Okay, so that's pretty simple enough. Until next time, take care of yourself and your family.